Hello everybody, this is Mr. Bright, and as promised, we're going to finish the imaginary complex numbers sheet today. So if you'd pull out your notes, we want to turn to the notes page on imaginary complex numbers where it says multiplying complex numbers. Okay? Now, before we get started with that, I want to just review a math concept that you've learned before, but I just want to review it real quickly. If I were to take the square root of 2 times the square root of 2, would you agree that this would be the square root of 4? And I know the square root of 4. The square root of 4 is 2, right? That the square root of 2 times the square root of 2 is just 2. And so it follows that the square root of 3 times the square root of 3 is the square root of 9, which is 3, right? So the square root of 2 times the square root of 2 is 2. The square root of 3 times the square root of 3 is 3, and so on. And so what happens is that the square root of negative 1 times the square root of negative 1 is negative 1. For the same reason that the square root of 2 times the square root of 2 is 2, square root of 3 times square root of 3 is 3, square root of negative 1 times square root of negative 1 is negative 1. Now, remember that the square root of negative 1 is I. So I times I, which is I squared, and so I squared is negative 1. Right? For the same reason, square root of 2 times square root of 2 is 2, I times I gives you an I squared, and I squared is negative 1. And so this can be confusing, and you have to watch out for these I squareds when you work on these problems. If we take a look at the top of our notes, multiplying complex numbers is just like multiplying with real numbers with one special case, that I squared is equal to negative 1. So take a look at example 12, where we have 5i times negative 4i. So the 5 times negative 4 is negative 20, and we have an I times I, that is an I squared, right? But we know that I squared is equal to negative 1, and so we're going to rewrite this thing. We're going to write it as negative 20 times negative 1, and of course I have a negative times a negative, and that is going to give me positive 20 as my final answer, right? That I squared has to be rewritten as a negative 1. You cannot leave it as an I squared. And so once it becomes a negative 1, negative 20 times negative 1 is a positive 20. All right, so you guys take a look at example 13 and see if you can do that one on your own. If you would, please pause the video. Okay, so 12 times 7 is 84. I times I is I squared. That rewrites as 84 times negative 1, or negative 84. So if you got negative 84, you did it correctly. Good job. Let's move on to example number 14. So in this case, you may recall that we have to FOIL something that looks like this, right? We have to multiply first times first, outer times outer, inner times inner, and last times last, right? This is why we call it foiling, F-O-I-L, for first, outer, inner, last. And so we've got to go through that process here. You may have learned it a different way, but you just have to distribute everything out, right? So when I multiply the 2 times the negative 3, that first term is a negative 6. I do the outer terms, so that's 2 times 5i. That is a positive 10i. The inner terms are going to be the 3i times negative 3. That is a negative 9i. And then the last terms, the 3i and the 5i, multiply to give me a positive 15i squared. So now when I look at this, right, keep in mind, right, we get that I squared, so that's what we've got to look out for. Right, that I squared is going to become a negative 1. Now these middle terms, the 10i and the negative 9i, those are like terms. Those I can combine together. And then that 15i squared, we have to deal with that I squared and turn that thing into a negative 1. So let's move down a step and try to do a little bit of this. The negative 6 is going to stay the same. The 10i minus 9i, I can combine those. 10i minus 9i would be a single 1i, or just I. And then that 15i squared, we're going to rewrite that as a 15 times negative 1. And so if I drop down one more line, I'm going to have this negative 6 plus I, and now minus 15, right? 15 times negative 1 is minus 15. So now, you might see it, we have like terms that we can combine again. The negative 6 and the negative 15, we can put those together, and so we do so. That gives us a negative 21, and then plus I. And that is my final answer. Now in the past, when you did stuff like this, you would have expected to get a trinomial, right? When we did this with x's, we'd get a trinomial when we'd FOIL something out, but that doesn't happen here because we get that I squared term, right? We get the like terms that combine right there in the middle, but that I squared is what ends up making the difference. That thing just turns into a regular number, and so we can combine it with our negative 6 and get that negative 21. Okay. So that's how that works. Just pay attention to your I squareds, make sure you convert all of them into negative 1s, and you should get the correct final answer. Okay, let's take a look at example number 15. I would like you guys to do this one on your own. Please pause the video and come back once you are completed. All right, if you got 9 minus 38i, great job, you did it correctly. If you didn't, take a look back up at this first line and see if you got everything here. 24 minus 18i minus 20i plus 15i squared. So the minus 18i and minus 20i became a minus 38i. The 15i squared became a minus 15. So the 24 and the minus 15 combined to give you the 9. All right, I do want to try one more. So let's take a look at example number 16. Again, please pause the video and come back once you have completed the problem. Okay, if you got 43 minus 24i, good job, you got it right. Again, if you didn't, look at that first line, 16 plus 12i minus 36i minus 27i squared. So if you didn't get that, go back and look at how you're foiling, make sure that you do that part correctly. 12i and the negative 36i become a negative 24i. The negative 27i squared becomes a positive 27. Okay, moving down the page, we need to look at dividing complex numbers. And I want to talk about what is written on this page. You have a plus bi and a minus bi. These are called conjugates, and in fact we call them complex conjugates. Conjugates are anything where you see this sign change, right? If I were to say, you know, x minus 3 and x plus 3, these are considered conjugates, but they're not complex, they're real. Complex conjugates have an I in them, so a minus bi and a plus bi. So an example would be 2 plus 3i and 2 minus 3i. It might be something like negative 4 plus I and negative 4 minus I. That the only sign that changes is the sign in the middle. All right, if the first term is negative, it stays negative. If the first term is positive, it stays positive. We just change the sign that is in the middle. Okay, so turn the page if you would, and let's take a look at these examples where there is division going on with complex numbers. So with division, we're going to take advantage of this deal with I squared being equal to negative 1. So in example 17 is a little bit easier one. What we're going to do is multiply by 3i over 3i. All right, we're going to multiply by that denominator. Now when we do that, this numerator we've got to distribute, right? The 3i has got to multiply times the 9 and times the 12i. So 3i times 9 is 27i, and 3i times 12i is a positive 36i squared. All right, I just distributed that 3i into both of these terms. Now that denominator, 3i times 3i, that is going to be a 9i squared. All right, so let's drop down a step. And so I've got 27i. I can't really do anything with that, but this 36i squared, have you started to see now that that is going to become a negative 36, right? It's just 36 times negative 1, so it becomes a negative 36 all over, and that 9i squared is going to become a negative 9. Now, we've got to go a little bit further. Remember how I said the I term has to come second? So let's rewrite this. So it's going to be negative 36 plus 27i over negative 9. All right, the only thing we're doing there is just moving the I term so it's in second place. Good. Now there's one more piece. Sorry, one more thing we have to do here is we're going to split this up. We're going to write it as negative 36 over negative 9 plus 27i over negative 9. I just took both of these terms and put them over this denominator. Negative 36 over negative 9 and 27i over negative 9. Now, all right, I lied. We're still not quite done. Because negative 36 divided by negative 9, that's an integer. That's just positive 4. Right? And then this thing, 27i divided by negative 9, that's an integer also. Positive divided by a negative is a negative, and 27 divided by 9 is 3, and then I have got my I. And that's my answer. That is dividing complex numbers. Okay? Now, that doesn't seem too awful, right? It's not too awful. So now let's make it awful. Let's look at example number 18. Okay, so recall what we did over here was we just multiplied by the denominator because the denominator was just a 3i. But there's more here. This 3i is just an imaginary number. There's no real part to it. It's not complex. This is complex. It's got an imaginary and it's got a real portion to it. So we have to treat it differently. What we're going to do is we're going to write this down. Multiply by the conjugate. Let me be more clear. Of the denominator. We're going to multiply by the conjugate of the denominator. Well, the conjugate of the denominator in this case is 3 minus 4i, right? And so this is what I do. I multiply the top by 3 minus 4i, and I multiply the bottom by 3 minus 4i. All right, this is just going to be a problem where we have to do a lot of foiling out, right? No two ways about it. You got to foil the top, you got to foil the bottom. So I want you to please pause the video for a couple of minutes. Everybody foil the top, foil the bottom, and let's regroup and see where we are. Please pause the video. Okay, let's look and see how everybody's doing. The purple is my numerator, the blue is the denominator, so that purple, 15 minus 20i minus 6i plus 8i squared. The denominator, 9 minus 12i plus 12i minus 16i squared. So that numerator, the negative 20i and negative 6i become a negative 26i. The 8i squared becomes a negative 8. The 15 and the negative 8 become a 7. So 7 minus 26i. The denominator, though, something kind of special happens. We have a negative 12i and a positive 12i, and they just cancel each other out, right? They go to 0. So I've got a 9, and this thing, this negative 16i squared, becomes a positive 16. 9 plus 16 is 25, and so I get this 7 minus 26i over 25. And I no longer have imaginary numbers in my denominator. So I am going to rewrite this as 7 over 25 minus 26 over 25i, because I like to be fancy. But even if you got here, that's fantastic. I'm thrilled, right? What happens in this denominator, the reason we multiply by the conjugate is because this will always happen. These middle terms will cancel out, and we end up with just a real number in our denominator. All right, got one last example. You guys try and do the entire thing on your own. Let me just make sure we get started off on the right foot. We're going to multiply by the conjugate of the denominator. So we're going to multiply by 8 minus 7i over 8 minus 7i. Okay, go to work, pause the video, come back when you're ready. All right, so if you did everything right, you should have gotten this thing right here, this 15 minus 112i over 113. I broke it up into two separate pieces. Right, but the main thing was that you're able to FOIL this thing out and get this middle number, these negative 56i and positive 56i to cancel out, and you end up with just an integer in the denominator. All right, so your homework is to complete the sheet from yesterday. So please do that, get that thing finished, and then turn it in for credits. Thanks a lot. Have a good day.